Hello, everyone. Super happy to be here. I was actually at the CityJS last year, but I was not speaking. I remember that was probably the first offline JavaScript event since COVID, and happy to see the crowd being much bigger this year. So today the topic, so I'm going to try to go fast because we don't have much time left. It's not a long talk anyway. So the theme of the talk is about reinventing Vue, and it's about some of the things we did when we upgraded from Vue 2 to Vue 3, which wasn't really a smooth experience, and there are some things that we learned, some things we want to avoid in the future, and hopefully that can help to help you take a look into the process of maintaining something that's being very widely used and have a lot of historical burden. And if you maintain something with a lot of users, maybe this is something you can learn from and avoid certain mistakes in the future as well. So about me, I've been an independent open source developer since 2016, and I worked full-time on VueJS and Vite. Previously worked at Google and Meteor, and my Twitter handle is at Youyuxi, which is the spelling of my Chinese name, and well, I refuse to refer to the app as X, but you know what it is. And my GitHub handle is that. So if you just go to the VueJS repo, you'll probably find me. VueJS, how many of you here have used it? Woo, all right. Not used it, but at least heard of it? Okay. So I assume most of you kind of know what Vue is and what it does, and but here I'm just going to go over a very brief timeline of how it came about. The first release with the name VueJS in it was in 2013, so technically it's like 10 years old now. Sounds crazy, but it's a pretty old technology at this point. So during this whole 10 years, obviously, it changed a lot. It evolved, and we added more stuff. We changed stuff. We did 2 full rewrites during this period, and the 1.0 was in 2015, 2.0 in 2016, which was the first full rewrite, and we started working on Vue 3 in September 2018. That was when we started announcing the idea about a potential future major version. And that took much longer than we hoped. Right? In 2020, that's like 2 years after we now started working on it, we finally did the soft launch, where we released Vue Core 3.0 as stable, but with some caveats I'll talk about later. And we only finally switched Vue 3 to the default version in January 2022. That's last year. So technically, I would consider it's Vue 3 is like officially out with only 1.5 years probably, because considering the September 2020 launch wasn't really the full launch. So this whole process took a really long time, and before we get into why it took so long and what kind of mistakes we did, well, I want to talk about some of the motivations, like why would we do it in the first place? Why do we do a new major version that changed so many things? The first obvious point is in 2018, so the Vue 2 code base is around 2019 is around like 2 to 3 years old, but we realized the code base needed to be modernized with the rise of TypeScript. So when Vue was first created, there were no type systems for JavaScript. Right? We slowly started seeing the rise of type systems in front-end engineering, and when we started working on Vue 2, the only TypeScript was out, but Flow was also an option, and TypeScript wasn't nearly as universal as it is today. So when we did the initial Vue 2 prototype, we didn't use any type system. We started with plain JavaScript and added Flow as a type checking option, but we didn't have full type coverage. So over time, we realized, okay, like this half-baked type integration is not really that much better than no types. And actually stuck with Flow for a very long time, and the upgrading process was also a pain because every single release pretty much broke something. So eventually we felt like, okay, we want to migrate over to TypeScript, but why don't we just do a rewrite in the process? To address some other things like some messy internal architecture, like how do we more cleanly separate the internal reactivity engine with the rendering layers, with the compiler layers, and how do we have the platform agnostic cores that can target, then we add additional runtime stuff to target the DOM, target Node.js, target edge workers, whatever, right? So the core should be clean and rely on only JavaScript and not any environment-specific APIs, so that the Vue core can run in any environment, right? Vue 2 wasn't really capable of doing that. We did that to some extent, but it was not really a clean abstraction. And then the compiler capability was really limited because Vue 2's compiler, per se, was forked from John Rezik's very simple HTML parser, and it didn't even have so it didn't have a plugin system. We cannot say like modify the rules. AST traversal was not really a thing, and we also didn't have any way to deal with the embedded JavaScript ASTs inside your templates. So a lot of things needs to be rethought and re-engineered. So we thought, okay, it's time for another rewrite. And at the same time, obviously, we want to make things faster, which we did too. And then we want to also rethink the API side of things. How do we address scalability and maintainability issues? One thing with Vue 2, so obviously the APIs themselves need better type support, right? As I said previously, when Vue 1 or 2, the original options API of Vue was created, types weren't nearly as universal. And so, frankly, the original API of Vue wasn't designed with type inference in mind. So it made it very difficult when we decided, okay, we need type inference, and how do we actually do that? If you've used Vue with the options API, you know that it relied a lot on the magical this object. And every option you declare in your component needs to be somehow merged onto the same this object. And for a period of time, it was simply not possible in TypeScript because until it shipped a feature called this type. And in some way, this type was kind of part of the motivation of shipping that feature was to help Vue do better type inference. And we actually had someone from the TypeScript team to help us, teach us like, hey, here's how you can use this type to actually make type inference work with Vue. So, but even with that, the type inference performance and the capabilities with Vue 2 Options API was still subpar, especially when you compare it to, say, React, right? So we decided we want an API that just plays nicer with TypeScript, designed with type in mind. So what's better than just function calls and returned values, right? Those always have the best type support. And we also need an API that addresses logic reuse and component refactoring. One thing we've noticed is that options-based APIs, when you have, tend to grow into really messy God components that are like several hundred lines long and with a bunch of different concerns mixed across a bunch of options, and they are extremely difficult to refactor. Simply because of the way options are organized. It just discourages you from plucking things out of these options groups and then somehow find a way to move them into an external file or group them differently, right? Options just does not encourage refactoring because it forces you to put your stuff in predefined buckets. So when you first use it, it saves you a lot of mental overhead because you don't need to think. You just say, okay, here's a computer property, I'm just going to throw in here. This is where it goes. But it also locks you into that structure. So later on, when you say, oh, actually, this data property, this computer property, these methods, they belong to a separate thing. I want to move them all out, but now it's much difficult because they are in different options groups. So a more free-form composition API was introduced, inspired by React hooks, and gave you the ability to more freely refactor, move things in and out of components, or extract them into reusable utilities. And And the final thing we wanted to do was to raise browser support baseline. We dropped IE 11 support eventually. That was still a thing that we kind of were weighing around at the initial release of Vue 3, but eventually we said, okay, we're going to drop it so that we can leverage new language features like proxies and future things that's going to come out, right? We don't want to be stuck with IE forever. So I'm happy we did that. But we also made some mistakes, and I'm going to be totally frank and talk about all these mistakes we made. It was not a smooth experience for everyone, and many users are, in fact, today still stuck on Vue 2, probably like 60% of them. The migration cost is a major thing to consider, and another major blocker is the dependencies. For example, a lot of users relied on, probably built their app on, say, Nux 2 or Vuetify, and they're pretty much blocked because those dependencies were not easy to upgrade. And finally, legacy browser support. Some companies, they do need to support IE 11 or like really old iOS versions, so they're stuck on Vue 2 as well. But I would cross out the legacy browser support as a mistake on our part. So the first mistake I think we made was too many small breaking changes, right? So the trap here is when you are thinking about breaking changes, when you're shipping a new major version, we tend to evaluate the breaking changes in isolation. So when you look at, if you go to our documentation for Vue 2 to Vue 3 migration and look at a list of maybe like 20 to 30 breaking changes, it's a lot, right? But if you look at every single one of them in isolation, you notice it's actually quite understandable and manageable. Like everything, when you look at it in isolation, you're like, okay, this makes sense. We should probably change it. And it seems straightforward to understand and seems straightforward to migrate. But what we didn't realize is the complexity compounds exponentially when you combine 30 changes all together. Because if you don't give the users a chance to pick off everything in isolation, then they're forced to deal with all of them at the same time. And this just results in a much, much worse experience when they are trying to upgrade. So the lesson learned is that don't break everything all at once. You should keep things working by default, ideally, and use the deprecate opt-in remove cycle. So the framework that did the best with this is probably Ember. What they did is when they want to break something or remove something, they would first mark it as deprecated, and then they give you the replacement, the better, newer API directly alongside the old deprecated feature. So you don't need to do anything. Things still work. You only get a deprecation warning. Then you can opt into the new fixed way of doing things. And then in a future release, they eventually remove the deprecated version. And they have a very well-documented process for this. So this is something we wish we did with Vue 2 to 3. We probably should have. I knew about Ember's policy like this when I worked on that, but now looking back, obviously it was a mistake that we didn't choose to do that, right? So another thing is you probably want to stagger and spread out between these changes between releases. Don't put all of them in the same release. Do a feel like, I feel like Angular after Angular 2 is kind of doing that, right? They do frequent major releases, but every release is like just small breaking changes. But over time, it can result in pretty impressive changes. And but the toll on the user is not as great as all these changes in one big release. So the next mistake is underestimating the impact on ecosystem libraries. Breaking changes were mostly discussed in the context of application level code. Again, this is like every breaking change when we discuss them, in fact, we had RFCs for these breaking changes. But when we were discussing them, we didn't have enough input from library authors. We mostly got input from application developers. And when they look at these changes in context of application code, they kind of understand this is what we need to do to change our code to make it work. But we underestimated how these changes would affect a library maintainer. And another aspect of it is we had a lot of these internal APIs. For example, the Vue 2 used the virtual DOM where the virtual node format is undocumented and not really considered public. But a lot of library authors actually kind of just inspected what properties are there and then start writing their code based on what's there. Unfortunately, right? And when we changed the internal virtual node structure, like the properties on the virtual nodes changed in Vue 3, we realized, okay, this is in fact blocking a lot of some of these libraries because they just are so tightly coupled with some of these internals, and made them difficult to upgrade, and in turn blocked the users of those libraries from upgrading as well. So the lessons learned here is ecosystem dependencies libraries are an absolute critical part of any migration paths. So when you're trying to think about breaking changes, always think about what are the most critical things in your ecosystem that may get affected, and actively reach out and collaborate to see what preemptively prevents this kind of situation from happening. You want to evaluate your breaking changes with libraries, advanced use cases in mind, not just like day-to-day application code. From the framework design perspective, we should probably discourage and even outright prohibit the use of internal APIs by libraries. Understand the cause of, and when that happens, we should understand the cause of why they're trying to do that, and try to address their needs with a public documented API so that when you are doing future releases, you don't accidentally break these things. Mistake number 3 is not releasing everything together. So as I mentioned, the September 2020 release of Vue 3 Core was a soft launch because although core is considered stable, many other things were still work in progress. For example, the documentation. We had sort of like a work in progress documentation that was mostly just kind of like latch on some explanation about composition API onto Vue 2 docs. But we didn't have a documentation that's targeted towards someone who's brand new to Vue and can learn the framework with composition API as a first-class citizen. And then the official libraries like Router and Vuex were kind of like in beta or RC phase. Migration build wasn't there. The dev tools didn't work with Vue 3 yet. Script setup was experimental, not stabilized. And important community projects like Nux 3 and Beautify 3 were far from ready. So the result of this is, so the reason we did the soft launch was we noticed that many users or library authors were just holding out on upgrading their libraries because they feel like, oh, core is not stable yet, so we're just going to wait until core is stable, then we start working on a new version of our library. So we're like, okay, we're going to just release core as stable so we can let them start doing that. But releasing core alone without a complete ecosystem caused confusion because users were like, oh, like Vue 3 is ready now, I should start trying it, but then they realize, oh, a lot of things are still missing and or not working completely properly yet. So it had caused sour first impressions, and these impressions do spread. Like people will like post on Reddit and say like, I tried Vue 3 and it sucks. And some people will like read about it and they hold on to that impression for years because they never tried it again after they read that, right? So these kind of bad impressions do last. And you kind of have to do a lot of like post like damage prevention later on to sort of convince people, hey, like we've made a lot of improvements since then, things have changed. So the lessons learned is first impression of a major upgrade really matters. You'd rather be late than incomplete. And to prevent, so there was a chicken and egg problem, right? So if we don't release stable, some library authors just don't want to upgrade their stuff. But if they don't upgrade their stuff, then the ecosystem isn't ready. So you need to find ways to gather feedback and work with these library maintainers to upgrade their projects before you actually do a stable release, right? You need to give them confidence in private, saying, okay, like it's not officially released, but it's stable enough for you to start upgrading your library so that we can all have the ecosystem ready and ship together. So give the user a much better experience. Okay, so enough about the bad stuff. So at least we did something right. So here's what went right. The first right decision was we embraced TypeScript. Now, type checking nowadays is just table stakes for front-end solutions. If you don't have good type inference, good IDE experience with TypeScript, people's gonna just think, oh, like this is from like what, 2013? And we also vastly improved the maintainability of Vue itself. So this sets up a very solid foundation for future iterations. And the second thing we did right was embracing composition. So composition API, I mentioned previously, it was inspired by React hooks, but rooted in Vue's own reactivity system. So if you are familiar with solid.js, Vue composition API is in fact much more similar to solid.js compared to React hooks. They are, so solid, Vue composition API, they are a completely different execution model compared to hooks, but they do provide very similar composition capabilities. So component logic reuse and refactor capabilities are key to scale, and this was one major thing that was lacking in Vue's original design. And I'm now confident to say composition API largely addresses that void and fixes that problem. And led to really strong community efforts like VueJS, which is a collection of Vue composition API functions, composables, that almost, if you think of some daily thing that's not in Vue core, look into VueJS, there's a very high chance there's a solution there. Okay. And the third thing that we did right was investing in DX, i.e. developer experience. One of the reasons that Vue 3 took so long is because I, in fact, spent a very big chunk of that time working on Vite, kind of like to kill time, to sort of like an escape route for me to deal with the burnout during the process. But it turned out to be something great. Vite is now serving as the foundation of a lot of new and upcoming newer generation frameworks. Nuxt 3 is on Vite, Astro is on Vite, Quick is on Vite, Solid Start is on Vite, SvelteKit is on Vite. So in fact, anything not Next.js probably is on Vite. Obviously, I mean, you can also use RSPack, which is also great. And then we did invest a lot of effort into rewriting the docs, redesigned everything, restructured the content to make it more up-to-date, all the new best practices for Vue 3 and new introduction flows, completely revamped the thing to support both Composition API and Options API at the same time. So that was important to onboarding users who are now just taking a new look at Vue 3. And then Volar, which is our official VS Code IDE extension, we actually spent a lot of effort into this, so we now get vastly improved IDE and TypeScript experience. So for a very long time, if you've only worked with Vue 2 with the old Vita extension, you're probably just used to untyped templates, right? And for a very long time, people were like, oh, the only reason I prefer React over Vue is because React has TSX and it has all the type inference. But if you never tried Vue 3 with Volar, you'll notice that inside templates, you get syntax highlighting, type checking, everything you get from TSX, you get the same in Vue templates as well. For Vue developers, the developer experience is just vastly improved. And the final thing is that with all these things put together, Vue 3 is indeed better than Vue 2 in almost every single aspect and is growing nicely. Right? It took much longer than we'd hoped, but today Vue 3 has largely fulfilled the goals that we started with, and now it accounts for over 40% of all Vue downloads and almost doubled growth in the past year. And the ecosystem has caught up and thriving, and I personally find Nuxt 3 really a joy to work with, and there are people working on new component libraries. So there are already pretty mature ones, and then there are new people working on these headless accessibility-focused components for Vue 3. There's Aku UI and Radix for Vue and all the exciting things that's coming. And there's someone worked on Trust.js, which is a Vue 3-based thing that integrates with 3.js so that you can use Vue component trees to render 3D scenes and all that. So exciting stuff coming. And for us in the Vue core side, looking forward, so stability is really the key, right? We want to let the ecosystem know that there's not going to be this kind of interruption in the future, right? No 2 to 3 style breakage in the future. Focus on improvements that are seamlessly adoptable, right? So one major thing we're working on right now is vapor mode. It takes the same template, compiles into something completely different under the hood, but it's opt-in, so you can opt in at the component tree level in your existing Vue 3 application, and it compiles those components into something more like the solid compilation output, which it plays really well with Vue's reactivity system. So it results in much lower memory usage and insane performance. And also in the future, we plan to do some lower level optimizations in the internal reactivity system and parser level. So these will be completely invisible at the API level, so the user don't need to do anything, just upgrade, your app becomes faster, your build becomes faster. So these are the short to medium term goals. Yeah, so the goal is to give the ecosystem a period of time where they know things are going to be stable, they can do all the crazy things built on top of the ecosystem, and at the same time, things just invisibly gets faster and more efficient under the hood. And that's our current strategy. So, thank you.